Gift subscription received.
Hey, what's going everybody? How are you doing? Happy day, chat. Hope you guys are doing super good. It's Monday and we're back at it with more Kerbal Space Program. Hope you guys are doing good. So we are going to kick things off where we left off on Saturday. Yeah, Saturday, right? Looking at hopefully finishing up our control testing with the DCX vehicle before we hop back into our orbital class launch vehicle and making sure that that thing is tuned appropriately. And then we gotta start seeing about the whole boost back automation, and also Nova coming in right off the rip of the stream with a gifted tier 1 sub to MT Shaw. Welcome, MT. Hope you're going to enjoy the no ads. That's right, no ads. Also, could you explain action groups quickly? Yes, I shall. Give me 2 seconds to find the thing that I'm looking for. Yes, and perfect. So I'm going to need a quick tutorial on how to use the DCX you uploaded. Goodness. Yes, quite right. So the DCX I just uploaded, what action groups do we even have, actually? Do we even use any action groups on this thing? I know we use one. Oh yeah, so that turns on the nose RCS, and I think that's the only action group, right? So essentially what this is designed to do is to go up to a certain altitude, say 70 kilometers. It then turns over into a belly flop configuration. You really don't need the nose RCS until you start going into the atmosphere to make sure that you stay stable, so that way you can actually glide it back towards the pad in the belly flop configuration. And then you need the nose RCS again when you do the flip over landing to burn. Basically, you know, you're flying in like this and you need that nose RCS to help right the craft to get into its landing mode. Other than that, the other thing that I think is useful to know is that if you guys are familiar with wedge shapes and aerodynamics, this right here with the flow going this way, this is a stable mode for this vehicle. Don't try to fly it level, like where this would be considered level, the straight edge. No, try to fly it going through the atmosphere in the belly flop configuration in the wedge shape, because that'll make sure you stay nice and basically just fall straight down. Because if you tried to fly it basically like an aircraft, using just the straight edge as like your wing, essentially you'll have side slip. But otherwise, I mean, it should be pretty simple otherwise. I had to give a sub to Shaw after all the racing we've done. Hell yeah, there you go. Thank you, Nova. But yeah, we can go through and run the code, which I have upgraded since Saturday. Uber, you might appreciate this. I went ahead and implemented a Cascade controller class, and yes, this now runs fully on a cascading controller. So I did finally get that working. We were on the right track. It was just a matter of tuning the gains and changing the signs, because some of the signs did in fact change with the change in control architecture. But yeah, no, other than that, it's pretty good. So yeah, we'll do a test run here to see where we left things off, and yeah, figure things out. Anyways, so this test that we're going to run should be approximately 20 kilometers in altitude, going higher than we were before. And then it's going to get into that belly flop configuration, and I'll explain everything with the vehicle as we're doing it. And then, yeah, we'll test the overall system. I also, I believe it was Caslo, or no, maybe it was somebody else. Somebody mentioned that this thing should try to basically hit an altitude gate, kind of like New Shepard does, where New Shepard comes in, right, from Blue Origin, comes in, it basically then hovers until it nullifies its rates, and then it goes down. So I have implemented something that I haven't really tuned yet by any means, but essentially what this should do now is come down belly flop style, like always, targeting the pad, and then it should hit an altitude gate, hover there, translate over to the pad, and then descend. We'll see. we'll see. It needs a lot of tuning. I haven't really tested that yet. I just implemented it, so it might not even work. But yeah, we'll see. We'll see what happens here, chat. I think that's probably just launch it, right? Just launch it, and that should probably tell us all that we need to know. But yeah, definitely excited to see how all this comes into play here. Wait for the code to connect. There it goes. And we're on our way. Advent of code, nice. Just had my first day of part-time work after over a year of unemployment. Well, very good. I hope you are enjoying what you're doing. But yeah, very good. Advent of code, nice. Yes, indeed. Well, I hope you're enjoying the stream, chilling out, coding while we code here on stream. All that jazz. So yeah, like I said, this should go up to, I believe I said 20 kilometers. That 20 kilometers is apoapsis, and it will actually burn past 20 kilometers to account for our coast period where drag and gravity are working against us. So that should be good. So it should probably stop around, like, I don't know, 20 kilometers, 20.5 kilometers, and then we hit our coast phase. As we see that sunrise, that Kerbal rise, there it is. Well, that's not a great start, chat. Let me tell you what. Did I add a 0 or something to it? Nope. That's definitely 20,000. Well, chat. I don't know what it's doing. I really don't. It got hung up somewhere. KSP or KRPC is doing something kind of gnarly at the moment. Let's revert that and see what's up. That's a great start. Great start to the stream. Round of applause, everybody. So no, that's definitely 20,000. That's not 200,000, so that's good. I was finding it weird that this never happened, so I'm wondering if KRPC or the game or whatever got locked into the weight. I'm kind of thinking that that's what happened, because it never. I actually had to hit the gear manually. So I'm wondering. Let's try that again. Let's run it back. Oh, now it's working, chat. You know how I know it's working? Because it does what it always does sometimes, which is just turn sideways and pull an Astra. Yo, and Portable Jim coming in with a Twitch Prime subscription. Much love to you, my friend. 5 Kerbal years for Portable Jim. May as well use this here. Well, I appreciate that. I hope you're enjoying the stream. All the rocket failures that are happening right now, right off the rip. What can we do, though? All right. Like I said, that should mean that it's working now. Believe it or not. Did I not hit the play button? Oh, I never stopped it before. Got it. There we go. It aims for fuel tanks. Yeah, pretty much. I'm wondering if I need to recover the craft file. I'm wondering if something is bugged out with the craft right now with KRPC, because there's definitely nothing that should be causing it to do that. Just saying. Yo, and Names No Names also coming in with a follow-up tier 1 sub for 7 Kerbal years on the Twitch side. Thank you very, very much. Okay, so what you doing there, guy? Also, it may have helped. Maybe I didn't help the system by actually hitting the wrong button as well, trying to correct, and I was actually not correcting it. All right. There we go. There we go. That's how that's working. Yeah, I wish I knew why that happens. Up there we go. Gear automatically retracted. It's working now, chat. Yeah, perfect. It really loves the ground, doesn't it? Yes, it does. All right, so now it's fully autonomous from here on out, and we'll see if we can't get back to the pad. Hey, what's up, Andy? How are you? I'm able to make a belly flopping starship. I just can't make it stable. Yeah, Yeah, the whole, like, once you get something working, then you got to make it work well, right? But Andy, that's awesome, man. I know you were asking about that on Saturday, about how to design your starship to belly flop. That's awesome. Hey, Terrace, what's up? How are you doing? Hope you're doing well. All right, should be about to hit coasting phase here. Probably like around 12 kilometers, we'll enter our coast period. That's probably gonna be mean sea level. Right there at 11.5. Now we're gonna coast up to 20. So you'll notice that we overburn almost to 21 kilometers because we have a estimator implemented in Python that's constantly checking the trajectory and accounting for drag, because the apoapsis in game does not account for drag on your vehicle. But because we basically burn and then coast, we have to account for drag on the vehicle if we want to accurately hit a apoapsis target. And so it looks like we'll be roughly, I don't know, 70 meters off of our perfect target, which is pretty good. Still more control than a shuttle I tried to make in Sandbox, Willie. I understand the struggle for sure. All right, so now that we're in this configuration, we enter a belly flop and we get into the wedge shape, because for this vehicle, this is actually the most stable going through entry. If we try to go wings level like this, it will basically get side slip because the aerodynamics really take control over it. So the wedge shape is just like in real life, pretty aerodynamically stable. And then now it's tracking the pad. So this is what I was talking about, chat. I implemented a cascading controller, which basically means we have two PID loops. We have a PID loop running our distance, commanding our velocity. So we have one PID loop that's based on our distance to the pad, implementing a desired velocity, and then we have a velocity controller that manages our pitch in order to try and hit that desired velocity. So we have an outer loop and an inner loop controller, and it's looking pretty good here. All right, it looks like we actually went a little bit past our target there. I wonder if it's going to be able to fly it back. It's going to try to fly it back. It's maybe not going to quite get there. So I might need to tune that controller a little bit to make sure it doesn't try to fly past it. Yep, exactly 70 meters past. All right, so this is going to be interesting, because if this works, it should hit the hover gate at around 30 meters off the ground, and then it's going to try to translate over to the pad. Or, you know, just go right into the ground maybe as well. Or whatever that is. Wow, great, great. So that did not quite work, chat, as I was intending. Actually, why did that not work? So we should have... Nothing ever works the first time you try it, chat. So we want mode 4, which is going to be the null, the horizontal velocity, and slew towards the pad. So what was my roll? So roll is... Ooh, things just exploding in the background. So we have float nan there. Target roll of 0. I think that's why it started to go out of controls, that it was trying to roll at the same time it was implementing all the other controls. So I am going to try, at least for now, to just not control roll at all. We'll see what that does for us. I think that's why I started to do that that basically spinning top maneuver at the end, as it was trying to roll while it was pitching, while it was yawing. And all of that at the same time basically was too much for the controller as it stands right now. Otherwise, that should be fine. That should be okay. And then we might need to tune the controller a little bit as well for the distance. Let's see here. That is maybe fine. Let's do a little bit less integral and see what that gets us. So that's our distance controller, which goes into our cascading controller. Okay, let's run it back, chat. Let's run it back. Yeah, not a bad try. At least the cascading controller is working, and that's good, and we have confirmed that. What's up, Graham? How are you? You've got me hooked on it, man. Did you see my comments in general chats? Yes, and that's it was you, I think, right, Graham? You said that it should hit a hover gate to then basically null out its rates before descending. I have implemented that, or at least we're on our way to implement that. I've got, I think, the code in, but we have to tune that entire control system. All right, let's run it back, chat, and I gotta get ready to correct it because it might do. Oh no, it was actually fine that time. All right. The wiggling that you saw was actually me thinking that I had to fight it again like last time, but nope, it just worked. I don't know why. It's the game. What can you do, right? I'm thinking of getting a game console for Christmas. Nice. Though I've been getting mad at myself because people tell me gaming's a waste of time. I gotcha. You're always going to find people that say that. You know, it's all just about how you, I guess, self-manage. You know, if it's something that you enjoy and that's your escape, then yeah. Like, it's essentially a hobby or something like that, you know? Some people binge watch shows, some people do outdoor activities. Gaming is fine, so long as it's not, I guess, everything, unless you're able to make it everything. There are people that make it their day job, right? Which is pretty cool. Just like New Shepard, that's exactly right. No, I didn't. I was the guy who figured out the landing error and your RCS on the bottom tries to rotate it sometimes. Yes. Oh, okay, I see. Yes, we did. I did look at that as well. I don't think I fixed that yet, though. But I know what you're talking about now, yeah. Yeah, it was? Yeah, okay. I thought it was you. Hey, Tyler, how are you? How are you doing? Pretty decent Monday. Good start to the week. Hope everyone's doing okay and sending some positive G's to those who aren't. Hey, fair enough. Appreciate you, Tears. All right. Let's see what we got. So we're coasting up here to 20 kilometers, mean sea level. What does it say we're going to hit? This time we're going to be at 90. We hit our altitude hold and then we kick over and get into the proper alignment, tracking the pad. Good. Good. Since you have a lot more time to glide into the target on a higher orbit entry, that's true, yeah. Yeah, we'll see. So right now it's commanding. So what we're seeing on the outer loop, this is our distance controller. So it's taking how far away we are linearly from the pad and commanding a velocity that we want to try and hit. So right now it's maxing it out, saying we want to try and achieve a 250 meter second track towards the pad. And as you can see, as we're increasing our velocity, -50 right now, -60, it's starting to come down. Then our secondary output, or our inner loop, is trying to command a pitch in order to match that velocity. So we're pitching down, trying to increase our velocity. It's now pitching up, trying to slow down as we get closer to the pad. So right now we are pitching up, trying to slow down, trying to hit 50. All right, that looks pretty good. We're right over the pad this time. It's now using the aerodynamics, flying vertically back towards the pad target. Ooh, okay, this is looking pretty good. This is looking good. It's not looking bad, chat. This will be the test of time to see if our slew towards the pad controller is going to actually work out. All right. So now it should try and stay here and hover. We do have a little bit of horizontal velocity going, and now it's tracking back towards the pad. This is not exactly as I intended, but I can't say I don't like it. It's a good thing we have enough fuel for this. That's all I got to say. Up, and there we go. We entered our gate for landing, and now we should be at -4 meters per second. Like I said, not exactly as I intended, but it worked. Okay, I like it. like I said, it could do better at trying to null out the rates faster, but I mean, you know, how far? We were 8 meters from the pad. We were 8 meters from our 0 point of reference, which was like right there. So pretty happy with that, chat. I'm actually pretty happy with that. I enjoy the outdoors, but Karen's, yeah, I get it. It has no drag and too much lift. Yeah, it definitely has a lot of lift, that is for sure. Let's see, I want to run it back and I want to see if tuning that horizontal velocity controller can give us some better results. Because right now, let's actually, why is it so tall? Stop it. Oh wow, it got really tall somehow. Okay, there we go. Because right now, if we go to mode 4, which is to null the horizontal velocity and slew towards the pad. This is all mode 5. Mode 5 is the constant rate of descent. All right, so when we were 13 meters from the pad, it was commanding 3 meters per second of velocity, and we were only achieving 0.62. It's commanding -4. Oh wait, did the signs change? This is our velocity and it's commanding negative. I think the signs are changed here because the vehicle is now upright. So instead of flying it like this, right? It's actually flying like this, like backwards. So I think technically this value is actually -0.44 because it's definitely moving towards the pad. So just like what we had up here, where negative, we were commanding negative and it was aligning with negative, I think, right? 30, and we were, no, that's distance and velocity. So distance is 30, we're +12, and every time step we're now moving away from the pad. So yeah, so it should be correct then. And then the sign changes because we're now starting to move back towards the pad, but we're hitting a negative value. Well, we'll have to see. I'll have to test that a little bit more. Just saw you're building a trajectory predictor in KSP with Python from last year. You've come a long way. Yeah, that's true. Yeah, we have come a very long way. So what you're looking at is, where is it? We still use that in this code, by the way. It's right here. Yep. We from a long time ago, made an Euler integrator just to help us account for the drag in our trajectory. And yeah, now we use that to basically get our altitude, which is pretty good. Let's see here. So mode 4, it depends. I don't know if we need to have a higher distance controller gain so that way it reduces the velocity. No, I think it's the H velocity, right? Yeah, I think it's the H velocity. Let's see. Let's try changing this to be a little bit higher. We can even change the integral term, but let's change it a little bit higher. And let's also set the maximum that it can be a little bit higher as well. So that way it can maybe try and, you know, maneuver a little bit faster to null out that velocity or to track the pad. We'll see. We shall see. Otherwise, looking good. You know, the other thing that we could probably do, chat, as just another concept is, so in our constant rate of descent mode, this right here actually nulls all of our velocity in the XY plane, XY being, right, the planar, not Z, not altitude, right? So I wonder if it would actually be best to completely null all of our rates and then enter a mode that tracks the pad, that tries to basically maneuver over to the pad. Because right now we could have essentially some sideways velocity, but we're still constantly trying to track the pad. So we're not actually nulling our rates. We're just trying to get to the pad. So I'm wondering if we actually need something like this to happen first until we hover, and then basically, you know, stop ourselves completely and then kick over and then land. Let's see, let's run it back and see what happens. And if it still does what it just did, so we landed over here, right? And then yeah, we landed like right here, and then because we had horizontal velocity on landing after the flip maneuver, we came screeching over this way until we were over here, and then it basically tried to track the pad, and then and then it finally landed, which isn't bad. I mean, it just, like I said, it's not exactly what I was intending, but anyways, let's run it back. Can you paste the new code? Yeah. Sure can. So we are using position and velocitygram. Yeah, we are using more than just a simple PID. We are using PIDs, but they're now in a cascading architecture, which is a little bit more robust than if they were just by themselves. So yeah, that's one of the things that we're testing out here. Let me paste that code. There you go. Cool. Yeah, so if you weren't here at the beginning, Graham, one of the things that I implemented off stream, whoops, where is it? Is this the right one? Where do I define it here? Cascading controller. So a cascading controller is essentially two PIDs in series. So this uses a distance controller to set a desired horizontal velocity, and then we have a horizontal velocity controller that tries to match that velocity, that desired velocity, using our pitch. So this is definitely a more robust way of doing things. It's still using PIDs, but it's a little bit more integrated. But yeah, definitely if we want to get more accurate, we're going to need something probably even better than just that. But I am just trying to see how it goes for the moment. I'm wondering why we aren't nulling the velocity in the mode where we are descending during distance and velocity loop. You mean when it's coming in backwards, trying to land? Is that the mode you're talking about? I think it's because, well, it's because I currently have it set to still track the target. What's up, Jeb? How are you doing? Yeah, it's because I still have it set to track the pad during that entire descent, using aerodynamics again. So, you know, we basically fly, if this is our pad, we're basically flying in like an airplane, it then pitches up, and if we're kind of still far away, it will then fly backwards using aerodynamics to try and maneuver over to the pad for landing. All right, should be set to shut down. There we go. You think you could integrate the RCS to help it do translations? Yes. To do that though, I don't actually know how to do that yet. I think that's where a completely custom flight controller will have to be implemented, which is a big project that I've kind of started off stream. I have a starting point for it, but it's going to be pretty involved. Because right now, just the autopilot that KRPC implements for us, that is currently controlling the craft in terms of its pitch and stuff, doesn't have that capability, as far as I'm aware at least. So yeah, we would have to set up our own flight controller to basically give I, J, K, L, H, and N inputs from the keyboard in order to do that, which would be a whole nother can of worms. A whole nother can of worms. All right, so we're looking good. That output's a little bit too long. Yep, we're tracking 250. Come on, come over here. All right, so right now we're tracking, we're still trying to get up to negative 200 meters per second velocity. We're now passing 100. We're closing that velocity gap. We're now pitching up to slow ourselves down because our outer loop is telling us we need to slow down because we're getting closer to the pad. We are now matching that target, pitching up. We are max pitch, and now we're right over the pad, transitioning into landing mode. Now this is some different behavior, chat. The heck? It's still in mode 2. It's still trying to fly. Well, that's weird. Huh. I wonder if it pitched too far and the aerodynamics took it? Because it never exited. It never got... Yeah, that was weird, actually. Oh my god, is it going to try and move all the way over to the pad? It's going to try to move all the way over to the pad now, chat. The lift is pulling it backwards, yes. And I do want that. You know, it's got to be able to slow down and speed up and whatnot, but yeah. All right, well, this is a great test for our pad tracking loop. Oh my goodness, chat. So we're at 14. Our outer loop is still commanding really high velocity, and it's not able to do that. It's still only commanding like 1 degree. Why? Is it because the sign difference, I wonder? Because technically this is saying it's positive 12, even though we're moving towards the pad, where it's commanding negative. I wonder if that's why. If it's this that needs to be changed. Not sure. It's gonna try, chat. We're just taking our rocket for a walk. Yeah, exactly. What's up, Houston? How are you? It's going to run out of fuel. I definitely need to probably implement, you know, if liquid fuel is this level, just enter mode 5, you know? Perfect. All right. Hey, what's up, weather guy? How are you? This rocket is your hero. Yeah, there you go. Is it possible to use threads so that telemetry can output in 1 second intervals? Yes. Yes, it is, actually. I just haven't done that yet. Yeah, exactly, Dino. Chillin'? Good to hear, good to hear. Mode 6 could be a secret abort. Yeah, I kind of agree with that. Because actually, I mean, mode 6 isn't even necessary. Mode 5 would just be it, because mode 5 tries to null out our horizontal velocity while descending. So I think that would be our oh crap, you know. Yeah, let me run that back, chat, because I want to see, is that going to be repeatable, because that was super weird. It probably is repeatable, but at the same time I just want to know why. I think it just pitched up too far, and then the aerodynamics basically flipped it over and it could never right itself back, and so then it just, yeah, could never do anything about it. Oh, that's right, the other thing I wanted to test was this. See, I'm worried that this actually might not do anything. Is it the same sign? Yeah, less than, okay. Yeah, it's the same sign. So then I think that should be fine, actually. Because it is working, it's just, for whatever reason, the controller is not controlling as much pitch as I would expect it to, despite there being a huge error in the distance there. I have to play around with that and see. Because our distance to pad was definitely over over 10 meters. But it was only commanding a pitch of like 1 to 2 degrees, which I would think that with a massive kilometer error. It would be pitching over way more than that. Because this was definitely maxing out. This was maxing out at like the maximum it could go, right? Yeah, negative 145. It was all the way up to negative 250 before on landing. So that's definitely outputting a reasonable value to be expected. But the horizontal velocity gain might be too low still for that control, for that mode. Yeah, it could definitely add some more integral for sure. Yeah, you just got to be careful with adding more integral, because that can flip your gain. It can cause it to become unstable very easily. I say easily, it's not necessarily easy, but yeah, can't add too much, otherwise it just flips the sign. No kaboom, everyone walks away. That's true. Think of all the grass you could light on fire. That's true, you're not wrong. All right, we are commanding 250 meters per second towards the pad. We're currently going 45, 46, 50. We are commanding negative 40 degrees pitch down. That's the maximum allowed pitch down angle. It should start pitching up here relatively soon to try and start slowing down. Okay, up to 40. Okay, it's holding 40. Seems good. Now it should be... It's still in mode 2. Yeah, interesting. And you see it's trying to pitch down, but it can't. Interesting, actually. Stand by. I'm gonna stop this. I want to read the outputs. Yes, it's going to explode. Chat, you want to see it explode? There you go. Beautiful. What is the output saying? Because it just commanded negative, or no, it commanded as high as it could. It finally got into mode 3 once the engines ignited, once it got too close to the ground. It started going negative, yeah, immediately negative. I wonder if I should put a rate limit. Could definitely probably put a rate limit on it. Because see, it went, how fast did this change? Pretty fast. It jumped by 4 degrees every time step, and every time step is roughly 1/10 of a second. Yeah, I probably need to smooth that out. Either the gain is too high for the horizontal velocity controller, because the horizontal velocity controller, in a cascading controller design, right, you have an inner loop and an outer loop. The velocity controller is the inner loop. And because it's working off of the distance, you typically want your inner loop to be much faster than your outer loop. So your gains on your inner loop should be much higher. So right now they are definitely a lot higher. I'm wondering if they're too high, particularly that that integral term. There's definitely different ways that we can help tune this. You're here for this content? Beautiful, beautiful. I think you're pitching down too much, so it's pulling you from the target. I'm not sure if there's a lift indicator somewhere. I mean, I could turn the lift indicators on. Yeah. Uber, add some KD. Yeah, we could definitely add some KD to try and reduce that response, smooth that response out. You know what? That's actually not a bad idea. Yeah, let's do that. I like that idea. We'll see. That might be too high. We'll see how it behaves once we run it back. So adding a derivative term in your controller typically helps smooth it out. So if you have either a lot of oscillations, it will try to smooth those oscillations out. Or if you have a really, really rapid response, it can help smooth out that response as well. So we'll see if adding that KD into the horizontal velocity controller makes things better. Let's just run it back immediately. Perfect. If you're new to the stream, that sometimes happens with the game when you recycle. I don't know why, but when you quick load, sometimes it happens. Usually that means it's working, funny enough. Yeah. Whatever reason, that happens. I'm trying to make a space plane fly, a space plane that can fly from the runway and go to space with a rocket engine afterwards. The rocket engine turns off before my fuel runs out. Can you help me figure out why? The rocket engine turns off before my fuel runs out. So, rocket engines, right? If you're using a rocket engine, it requires oxidizer and liquid fuel. So my first question, just based off of what you said, you're not just talking that you have liquid fuel remaining, you have both oxidizer and liquid fuel, right, Malcolm? So you need both of those, yeah? The other thing I can only think of is if... Yeah, do you have that first? So yes, okay. The only other thing I can think of is if somewhere with your fuel tanks, if you have like a decoupler or anything like that that impedes the fuel flow, that would be the only other thing. Because there are certain parts in the game, for example, this docking port, you probably don't have a docking port in your craft between fuel tanks, but let's say you did. I can right click it, right, and I can disable crossfeed. So there are certain parts that actually allow you to toggle if fuel can go through it. So if you have one of those parts and it's set to disable crossfeed, then that might mean that fuel that you're trying to use is not able to get to your engines because your engines are behind that part. Or I also, if your fuel tanks are like attached via a panel, like one of those structural panels, those don't allow fuel crossfeed either. So that's just a couple of starting points. Without directly seeing your craft file, I can't say more at the moment. All right. Let's immediately run it back and see if we get anything different in response. Oh, that's right. I should have... Gosh dang it. I forgot. I gotta hold the S button down when it takes off. Otherwise, it's just gonna nose into the ground. I did see that Uber. Yeah, I did see that. Yeah, excited to see where that goes. Every time, chat. For whatever reason, like I say, when you quick load a quick save, sometimes that happens. I don't know if it's KSP, I don't know if it's KRPC, the mod that we're using, but for whatever reason that sometimes happens. Hello? Oh, it never stopped. Got it. There we go. Yep. For whatever reason, it wants to do that. There we go. Quantum meal. I dig it. Underrated meme there. Flight control test phase. What do you mean? That's kind of what we're doing right now, yeah? Yeah, we're in the flight controller test phase. Suppose that's accurate. The cybersecurity professionals are sweating. Yeah. All right, should be coasting up till 20. You know what? We can time warp. This thing should be stable enough to time warp here. It won't be as accurate on the shutdown. We'll go a little bit higher than I would otherwise intend, but that's fine. And we'll go up until we hit our apoapsis here. Enter our brief altitude hold and turn over. There we go. Yeah, exactly, Graham. I don't know why. I don't know if that's KSP, like doing something weird behind the scenes, that KRPC just is a victim in that sense, or if KRPC, the mod that we're using, does something weird on like a quick load and has to like reset. Yeah, I'm not sure. Like if it's a control point difference or, yeah, I don't know. All right. So we added some KD. It helps smooth out our velocity controller a little bit. No, stop it. So we're now going 100 meters towards the pad. We're tracking 150. It's starting to pitch up. That seemed a lot smoother. We're now maxing our pitch. Oh, that's where I want it to do that. So that was good because we went past the pad. So now it flipped over trying to stop. And now it's basically flying backwards back towards the pad. So this is actually correct. What it was doing over here though was not. All right, so engines are now on. It's trying to track the pad with the engines. Yep, looking good. So it did a little bit, yeah, I probably need to tune that distance controller. But we'll probably have to, I want to kind of avoid that because I think the distance controller is going to be fine, especially once we start going higher, and it's going to have to command higher velocities anyways, so. So that's me doing a little bit of sideways input, but it's controlling the pitch and everything. All right, looking good. Can I just, oh, I can. I can now manually, oh, we're just gonna burn the flag. That's fine. We're just gonna go right over the flag. All right, so now this is interesting, yeah? So where are we? Because it's not moving towards the pad anymore. And it's commanding negative 0.3 degrees. Despite us wanting a 20 meter per second velocity towards the pad. Yeah, so something's not doing it at the moment. All right, stand by. Let's get it over the pad so it lands. So I'm doing the RCS, just trying to move us towards the pad if I can. So if we get it close enough, it should hit that gate to then start descending. Oh, there it goes. Descent. Oh God, we're running out, chat. We're running out. Oh, there we go. Steady state. I mean, yeah, but it does have an integral term. We just need that much higher of an integral term. I can't imagine that being the problem. I mean, it could be, but we do have an integral term, and it's actually kind of low. I was actually thinking it was higher than that. All right, let's just, you know, make it an order of magnitude higher. Let's see. Because you're right, it is, I guess, kind of a steady state error. It's just, it's not winding up the control input like it should be. I think you need to wait till a lower velocity to stop using aerodynamic guidance since you aren't like fins. Oh yeah, so you're saying like we're flying in toward the pads, the engines turn on, so we then switch moving towards the pad, but we're still basically aerodynamics are too high. Yeah, I implemented something like that previously, and I think we turned it off during the last refactoring, but it might be time to add it back in since we basically have a different trajectory now. I think it was here. So if burn flag is false, we're pitching away from the pad. But if our burn has started, we're now burning towards the pad. But we could add a, we could add a vessel dot flight dot vertical. Is it vertical velocity? I'd have to look at the docs real quick. Actually, do I have vertical velocity started here somewhere? Stand by. I was kind of thinking I did. Tilim. Because we have our telemetry set from our control point, mission.telemetry, and telemetry is defined as Vertical velocity, that's what we want. So it should be tlim.verticalvel. Okay, so we do have that already implemented. So I want instead to scroll down here. So it should be tlim.verticalvel. And if that is actually, should it be vertical or should it be magnitude? What do you think, chat? Probably magnitude, right? I kind of see it going both options. Where did I define that? Mission.py. So yeah, we have our velocity, which is just our speed. Yeah, okay. That might be better. It's pretty cool, actually. You have all of your cameras showing at the same time. You know, somebody mentioned that before, and I forgot to look at it. So I'll do that right now. Pull it up and keep it for me to check out. Of course, I still love you, mod KSP. Of course, I still love you. Watch all your whole camp. Is something wrong with the forums, chat? Are the forums down? Huh. What units do you use for vertical velocity? It should be meters per second. What about magnitude? Yeah, that's what I'm kind of using here. We're using speed for our velocity, which is technically not correct. Now that I'm thinking about it, because the velocity, of course, is a vector, but for now we will keep it simple. Is if it's less than, say, 50. Probably gonna need to be higher than that. Let's do 90, because it comes in pretty fast. Centimeters per second. That's fair. That's fair. They're down for you. Okay. Interesting. Yeah. Well, I have it pulled up on GitHub, so that should be a reminder. But yeah, the KSP forums are down, I guess. What you could do is have a PID slowly transition to tilting towards the pad using engine control as you lower speed, so it allows more control to the engines with lower speed. That should be how it's set up right now, Graham. I know it's a lot to go through, and it just is, you know, your eyes glaze over seeing all of this. But we do have the PID set up to pitch towards the pad. Up to 15 degrees. Like, so this is vertical. It should be able to pitch all the way 15 degrees off of vertical to transition over to the pad. So yeah, like I said, what it's doing right now is not what I am actually expecting it to do. How do you know all of this? We've been at this for quite some time. I mean, this is actually what I went to school for as well, at least partially, not this directly, of course. But like control systems and whatnot, I learned at university. What was the other thing I was going to check, chat? Horizontal velocity. Oh yeah, that's right. So that's mode 4. Mode 4 is to move towards the pad. Wait, what was this mode then? Mode 3. Oh no. Okay, sorry. That stays. That should stay. No, wait, no, that should not stay. Okay, no, I was right the first time. And then we want to null and salute to the pad. And then after that, we change to a horizontal velocity control. Okay. That should be fine. So we did change that already. So I added more integral to our horizontal velocity controller to try and see if that helps us push ourselves to the pad more. It has a positive and negative 15 degree output possibility. So, I mean, I'd like to think that this should track the pad. You have your master's. I have my master's, PhD. Yep. I finally got the doctorate. Yeah, Graham. I like I said, I think we have all the pieces there. It's just now about tuning it and making sure, you know, we're actually using the things that we need to use, right? Like making sure we think of all the possible contingencies, making sure that our, you know, that we're using the right values and that everything is being cohesive. All right, we're gonna go a little bit higher than our target, but that's because I was fast forwarding. yeah. All 3 from Embry, that's right. Wait, no, not all 3. Just Masters and PhD from Embry. Went to Georgia Tech for my undergrad. So Georgia Tech, Embry Riddle. King, yeah. There you go. You wait, what? What's that word? I did not go to school for English, so I don't know what that means. No, it's not a word. Okay, I was just checking. ERAU, yeah, ERAU. Yep, Daytoner. Spaceflight operations. My business partner went to ERAU for spaceflight operations. It's a lot of like policy and regulations, or at least when I was going there, but they were in the process of revamping it. So I don't know what it's like now. But a lot of it was like you could do a policy track, you could do an operations track. And I think they were revamping their operations track to try and actually be more like commercial operations. From what I remember anyways, it's been a minute. Oh, this is looking kind of nice, chat. Look at that. Belly flopping right down to it. Once we hit a... Yep, there it goes vertical. I was about to say, once we get within 50 meters of our target in the linear space, it should... Okay, looking good. Back in the pad, engines are on. So we're coming in sideways. So let's see if it'll be able to null out that velocity now. Oof. Oh, that's looking much better, chat. That's looking much better. It's still, you know, oh my God, you know what it actually is, chat? I know what the problem might actually be. I don't think we implemented a yaw controller. So this is only doing pitch, so we're only controlling one direction. I think that's the issue. My son went to ERU for aerospace engineer. Hell yeah, Gilmere, nice. Congrats on that. That's awesome. That's an awesome achievement. But look at that, chat. 6 meters that time. The only thing I did was a little bit of the RCS control at the end so we could actually slew side to side. But I think that could be the problem. If we actually look at the control system, right? We are in this control mode. And we do have a control setup for our target heading. But this isn't the same thing as yaw. At least to my understanding how KRPC's autopilot is implemented, this is not the same thing as yaw. This is essentially our orientation that we want our pitch to go, right? So you can imagine it's a little bit different from yaw, right? You can imagine if we're flying like an airplane, a compass heading, which is this heading, is north. And then we're controlling pitch. So if we're basically trying to change our heading to aim towards the pad, and we're only controlling pitch, we're not actually controlling yaw. We're actually, when we're sitting vertical, we're actually controlling our roll. I think that's how the autopilot is set up. Are we controlling our roll when we're doing our target heading? Because if we're vertical, then the only way that we can change our heading is by rolling. We're not yawing to change our heading. I'm pretty sure that's what's actually happening. So if we really wanted to be able to null all of our rates, wait, how do we do this down here? Calculate the heading using ATAN2. We have a pitch input. How is that handled here? Space Center, autopilot. Is it control? No, autopilot. There it is. I wonder what sort of people make up mission control rooms of SpaceX and Blue Origin, what kind of degrees they're experienced. Typically, they're engineers, Ubernator. At least to my knowledge, like most of the people that you see as like launch director and whatnot are just like really senior engineers that then moved into like the management status, you know, management, flight management. Like the guy that used to be the launch director, or the launch director at Astra, he actually started off as a technician, and then became a lead for like the Astra like systems engineering side of things, and then moved into the Astra launch program and launch management. So that was the track he took. So I don't think there's like a specific, there's not a specific degree to get into the control room, so to speak. See, target heading, the target heading in degrees 0 to 360. So this is compass heading. I don't know how that translates to yaw, because it's not the same thing as yaw. And I don't know how the autopilot allocates that control. See, this is what I was thinking about. Okay. Quick tangent here. So what I was saying earlier, I started offline working on a flight controller. And this flight controller you can kind of think of as what's known as a stability augmentation system. And the flight controller is, again, a set of PIDs, but there's one for controlling pitch, yaw, and roll. And specifically, it actually uses the vector direction of your vehicle. So that way you can actually get, I know I called it heading here, but it's actually the rotation in the X, Y, and Z plane of your spacecraft or aircraft. So it's actually using direction angles, and it's not using like heading, so to speak, or, you know, like explicitly, or at least it shouldn't be how I have this set up, because this is all relative to the body axis of the spacecraft. And it should take a direction defined by your guidance algorithm, right? Your guidance basically defines where you are relative to your target and inputs or outputs, you know, the required parameters for then your navigation system to say, hey, we're this far, we're here, we know where we are and we know where we aren't, right? So here are the control allocations for the controller to then implement to move ourselves to that desired location. So that's what the seek direction is. We basically get a vector of how we want to point in our spacecraft body frame. And if we want to point this way, but our spacecraft is currently pointing this way, it should then do all the control allocation to then get on that correct direction vector. I haven't tested any of this though, and I have no idea if this would even work, but I'm wondering if something like that would be required to truly be able to control ourselves back to the pad. Because right now I have no idea how the back end is handling heading. Who uses heading and control unless you're an aircraft? Anyways, what's up, Erudite? How are you doing? I gained a data engineering title with only an AS, so much of it is networking and everything. Associates? Is that what's AS? We know where we are because we know where we aren't. Exactly. Currently at ERAU, did you ever work with Seo? That name does not sound familiar to me, but maybe I saw them. Oh, yeah. No, I know this guy. Yes, I did. I never worked with him, but I definitely know him, yeah. I've definitely seen him in the halls and things like that while I was there. Yeah, I know of him, but no, I did not work with him. What is his main focus area in terms of research? This seems super chill. Well, welcome. Yes, I hope you enjoy the stream. We are coding and launching rockets at the same time. Talking about aerospace engineering right now. Yeah, a show teaching science. Nice. Yeah. 2-year degree, though it's often more than that. Yeah, exactly. Yeah. You can always just translate it to a new reference frame. Yeah, you can. There is a transform, but I'm hesitant to get into like the whole reference frame rabbit hole. Controls? So I worked, if you know Dr. Mancayo, I worked with Dr. Mancayo. PRAU, SEO. Let's see here. Oh, UAV and underwater vehicle control. Nice. Flow field control systems. Currently, his work is focused on the performance improvement of the conventional adaptive control method and the development of the attitude actuator for the small satellites. Awesome. Dude, that's really cool. So yeah, I know of him, but no, I did not personally ever work with him. I didn't even take a class of his. I don't know if he teaches graduate level. ERU is so expensive. Oh my god, every college nowadays seems expensive. Let's run it back and see how if we can repeat that. I know where I am because of a given chance in some superposition I will arrive at some point. That is true. That is true. I use PCI and the northeast upwards on non-rotating parent. So northeast gravity is my best friend. Hey, there you go. Yeah, that's definitely typical, at least in my experience, obviously, for like aircraft systems or things that fly in the atmosphere. But for satellite, no. Well, at least I've never worked with satellite systems with the northeast down. But that could just be my line of work. I don't think, satellites wouldn't use northeast down, right? They have their orbital reference frames, they have body reference frame for anything. Whether that's ECI, ECEF, local horizon reference frame. You got accepted into Embry, but I can't afford to go there, going to ISU instead. Hey, that is understandable. I'm not familiar with ISU. Am I just being silly? Oh, Idaho. Oh my god. For a second I was like, what is that? Yes, Idaho. I'm sure you will have a great time there. So like my whole thought with college is I think all of it is way too expensive. Like the only reason why I was able to go to Embry for my graduate courses is because as a graduate student you can go there and basically become a teaching assistant and actually get paid by the college to attend. I was lucky enough to be able to get into such a program. Otherwise, absolutely not. Colleges are so stupid expensive nowadays. Like, I don't think I could nowadays afford to even go to my undergrad that I did, because when I attended undergrad 12 years ago now, good lord, I'm old. It was still expensive, but it wasn't expensive as it is now. Like, yeah, I understand. How much does ERA cost? Yeah, it costs like 50. Indeed. I was actually thinking it was more than that, but yeah. It's somewhere around there. The Starship engineering lead was there a week ago. That's awesome. Chatting with people, hell yeah. That's good. I mean, I think, so what's great is that because the space sector is completely taking off, there are a lot more colleges now than even just 10 years ago that have really ramped up their aerospace engineering degree sector, or their engineering domain, whatever you call it, their engineering degrees. Like Embry-Riddle, honestly, at least as far as I'm aware, wasn't really that big in terms of academic aerospace engineering until even I went there in 2018. And that's after a lot of, a lot of the aerospace engineering field just completely took off. Now, see, why is it doing that? Did it enter mode 3? No, it did enter mode 3. I don't know why it's doing that, though. Did I forget to change something? I may have forgotten to change something. But anyways, yeah, like, I totally get it. But yeah, now there are so many universities that have really great aerospace engineering programs that, like, didn't even have an aerospace engineering program like 4 years ago. The first one that comes to my mind is Tennessee. University of Tennessee has a really good aerospace engineering program that really just started taking off like in 2020, like right before COVID. And there's so many more like that now. All right, well, it's tracking back to the pad chat. Is it going to start stopping? Come on, Start stopping. You're overshooting your target. Up, 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 up. Come on, stop it. This is hilarious. All right, you're overshooting again. Okay, so that might be too much gain. You see how much it's like really trying to overcompensate now? It's like maxing out its control. I mean, it gets there, it just overshoots. So that tells me it's going to be way too much of a proportional gain on that particular controller. Do you have a Discord? I sure do have a Discord, yeah. Yeah, Ubernator, I hear ya. I hear ya. So I think that was this. We did change that. So that used to be, I think, 0.6. Let's bring that down to 0.5. We still have our integral action working. Everything else I think should be fine, and that should be in mode 4. Yes, mode 4, cool. Needs more KD. It could also use more KD as well. Actually, that might be the better move to do, because I'm seeing now we don't actually have any KD on this particular controller, so let's make that equal to our integral action. So yeah, it's a good call, Houston. I didn't see that this was zeroed out. Okay. So not bad. The one other thing I wanted to check is in mode 3, why were we still pointing away from the pad? It was from this. Is it because of our velocity? You know what? What do we not need right now? I don't need this right now. Do that. I want to print out my velocity term and make sure that it's actually working, because it was that entire time after we passed the pad, it just stayed pointing away from it, and I don't know why. That was a little bit weird. Nope. Stop. I need to refuel. Need to revert. Seems like you're not accounting for mass or momentum. I mean, we kind of are indirectly. Not directly though, Terrace, you're right. Like the PID loop is accounting, so to speak. You basically use a PID to account for things that you can't directly account for, if that makes sense, right? Like we're using our PID to try and control our velocity term. And that velocity term is relative to our velocity movement towards the pad and our distance away from the pad. So therefore, inadvertently, we do kind of keep track of our momentum. But I think the gains right now are too high because, as you saw, you know what? This might be a great teaching moment, chat, to bring up paint. Flashbang out. Yes. Brilliant. Boom, right? So when you talk about a PID, you have 3 gains, right? You have your proportional gain, you have your integral gain, and you have your derivative gain, right? PID. So when you have a proportional gain in your system, let's talk about high versus low, right? When you have a really, really high KP, and you have a reference, like a step input that looks like this, a really, really high KP is going to have a very, very fast response, but it's going to have oscillations typically, right? That are going to smooth out over time, but you'll have a fast response, but it'll overshoot. You'll have these peaks and troughs, and you'll basically oscillate around your desired vector. But on the other hand, if you have a low value, your response is going to be a lot slower, right? So you have to try and find that medium ground just using your proportional gain. You have to find that medium ground between high and low value. You can also have your KI, right? Now for a KI, that's typically great when you have a steady state error. For example, if you have a step input on your system that you're trying to track, a very, very high KP is again going to basically meet you. It's probably also going to introduce oscillations as well, but it's going to actually help drive your value to that over time. Because if you have a low KI or no KI at all, you might find that your proportional gain will get you only so close to your desired input, your actual desired value. So as you get that integral term higher, where you're now starting to account for the amount of time that you are away from your desired state, it will start increasing your control output until you get that to basically 0, right? And then finally, when all else fails, not when all else fails, KD is very good. KD will help smooth out your overall trajectory or your overall input. So if you have a really, really high KP and a very, very low KD, what you might find is, again, you'll have a lot of oscillations, right? If you increase your derivative term, that will try and smooth out your overall response. So this is what the KP, KI, and KD are all designed to do together in a proportional integral derivative controller. So you try to use all 3 of these values to find the perfect response relative to what you want your system to do. And it's all about finding those through testing or through analytical means, what those values need to be, right? So it's involved. Let me tell you what, it's involved. Right, you're counteracting and influencing the motion effects of momentum, don't need to track the mass itself. Exactly. Exactly. You know someone is smart when they can draw in paint better than you can write with the pen. Oh, that's funny. I highly recommend joining both the KRPC Discord and the Rocket Guide Discord. Then you can poke people for help if you want. That's true. What'd you say, Garu? I have never seen the side of KSP actually coding the rockets. I'm going to take online courses now just to do this. There you go. Well, if you want a starting point, Garu, if you I don't want you to look at this and, see all of this and then get overwhelmed. But all of my stuff is open source. It's on GitHub. You can see it tagged in the video description on YouTube. So if you want to take a look at it, even if you don't know what any of it does right now, also on my Discord, I have this vehicle posted, and I also post my other vehicles to Kerbal X. And I do plan on posting this vehicle to Kerbal X if I can remember to do it either tonight or tomorrow. I do this so literally anyone can download the code, download the game. It's all stock, and you can basically fly and play around with it yourself. So, yeah. Hope you enjoy the can of worms that you're about to get yourself into. 100%. I sent a GIF in general of how this works. I'm not sure if you can show that in real time. A GIF. Oh, in Discord? In the Discord? Aha, yes. Oh, very good. Yes, open browser. Yeah, this is the classic GIF of what a PID loop does. So yeah, let's go ahead and reset. So starting at KP equals 1, notice that we have a steady state error. Notice as we increase our proportional gain, we get more oscillatory, but we also get a faster response. And as we increase our KI, we start reducing that steady state error until we start getting more oscillations. And then finally, we add our derivative term, which smooths out the entire thing, the entire response. So yeah, we're now adding KI to reduce that steady state error to 0, but it gets more excited. And then finally, we increase our KD to help smooth out the entire response. So yeah, great teaching tool, Graham. Thank you very much for that. Yes, indeed. I gave up on KOS when I got to PIDs. This was a long time ago. Hey, fair enough. Yeah, exactly, MT. Yeah, right? So yeah, this is what we're implementing in real time here on stream with our code, trying to make it all happen. Uh-oh. What does that say? Oh, can you still load it, Uber? Because I actually got rid of all of the cameras, but if I guess it still has the module from it having once had the cameras on it, can you still load it, or it doesn't even load? Because it should be fine. Like that shouldn't matter. I took all the cameras off, but it might still have like the modules attached to it in the file. Yeah, let me know. But yeah, by the way, chat, there in Discord is the DCX vehicle that we're flying right here. So let's run it back, chat. So hands off the controls, actually, just in case it flips out. No, we're good. Okay. Hands off the control. Let's see what it does. In From the Depths. You know, I know that game. Or well, I don't know it. I've heard of that game before. But yeah. I built a lot of capital ships for things like Mars missions. I want to learn how to do this so I can launch multiple rockets to shorten my build time. Awesome. Awesome, yeah, that's cool. All right, weather guy, have a good night. Thanks for hanging out and stopping by. That's so beautiful indeed. I know, right, King? PID tuning is an art. There is no one way to tune a loop. Those GIFs and articles you can read about tuning will get you in the ballpark, but ultimately every plant is different. Yeah, every plant meaning system model or system in general if you're working directly. Yeah, stupid plants indeed. I can't wait for KSA might allow you to do coding. Oh, that'd be sick, yeah. That'd be really cool. All right, we're now coasting up to 20 kilometers. Let's go ahead and time warp a little bit. And shut down, enter our brief altitude hold. And pitch over into our belly flop. Get ourselves situated. It's now tracking the pad. We have our outer loop controller targeting negative 250 meters per second. That's 250 meters per second towards the pad. Our inner loop controller is commanding negative 40 degrees pitch down in order to increase our velocity towards the pad. So you can see that number starting to decrease. It's now moving towards the pad. Negative means we're moving towards it. Still commanding, so we try to track 250. Overall looking good. Hey, what's up, Mad Chad? What's good, man? How are you doing? Does KRPC have an API call to pause the game? I think they do, Ubernator, if I'm not mistaken. They do for time warp, so I couldn't imagine they don't for pause, but I haven't checked. I'd have to check the docs real quick. All right, we're pitching up to slow down. Yeah, pitching all the way up to slow down. Looking good. And now we're over the pad. Oh, look at that, chat. It's still trying to... Wait, are we in the other mode yet? Yeah, we are in mode 3. Did I change something? Did I change something, chat? If I did, I don't know what. Because now it wants to aim towards the pad all the time. Why? I did change something. I did this. Last is... Wait, so mode 3 output to lim.velocity was last? Hang on. I love how it just goes for a walk, chat. So mode 3, no, that's mode 4. Mode 3, 288. $70. Interesting. Oh, it overshot. So that still not enough. Still not enough. See how it's maxing it out? Yeah, we're almost to max 15 degrees. Yeah, definitely need more derivative. Is greater than 90, so it's moving away. But it shouldn't. It should be moving towards when it's above 90 and then moving away once the engines are on. Well, we can actually update those on the fly. We don't need another mode crisp, but yeah, that might be required. But yeah, see how it's essentially oscillating back and forth really large? Although, to be fair, we started way over here, and then we came over here. If you imagine this as a graph, right? We basically started over here, came over here, and now we're coming back, and now... So it should be basically doing this until, ideally, it gets to 0, but... not easily. Not before we run out of... Not before we run out of fuel. Cap your horizontal velocity and retune, yeah. Well, see, I want to try avoid tuning so much because I want this to go all the way up to 70 kilometers. And when we change our trajectory, right, we're going to have to retune it anyways. So it might just be time to send it up to 70, see what happens, and tune it for 70, which is going to be our desired flight envelope. our desired launch trajectory. But I was hoping we could do these suborbital hops, or like these little tiny hops, to be a little bit more effective. So if burn flag is false and velocity is less than 90. Oh. Ah. Is that what you're trying to tell me, Graham? Stand by. Is that what you're trying to tell me? Oh, God. Okay, no, we're fine. I thought it was doing the tip over. Just saw the Spatial Discovery today at Air and Space Museum. Hell yeah, Alex. Nice, man. Nice. The Astra Power Slide. You know it. You know it. Yeah, it's because it needs to be greater than, because we have the and, not the, it isn't, not the or. Yeah. No, actually it should be an or, right? Not an and. Hold up, hold up, hold up. We have some time. It's coasting up to its apoapsis. Where is that? So if burn flag is false, if it's false, it should be moving, it should be aiming basically pitched away from the pad because it's flying backwards towards the pad. And the velocity is greater than 90. No, that should be fine, right? And then if the flag is true and our velocity is less than 90, then we should pitch over towards the pad to use our engines to move us that direction. Okay, that should be fine. That should be fine. You say send it to 70? Yeah, it's probably where we're about to go. Yep, that all looks good. Probably need this to be a lot higher as well. Yeah, remind me, we'll do one more test after this to see if increasing our derivative term in our velocity controller is going to help our slew towards the pad. All right, enter our altitude hold and start our pitch. Enter belly flop, and we belly flop again. You could dynamically limit horizontal velocity as a function of elevation to ensure... Well, that's actually not a bad idea. As a function... Well, I don't know how that would work, but I guess that wouldn't... I'd have to think on that one, Terrace, because right now we're using our linear distance to the pad, basically our downrange distance, to manage our horizontal velocity. Because you see what it's doing right now is, because we're so far away from the pad, it's commanding 230 meters per second. And so we are pitching down, trying to increase our velocity to match that as we're moving towards the pad. And then as we get closer, of course, that's going to start wanting less and less velocity, which is why we start pitching up to try and reduce our velocity towards the pad now. There we go. We went vertical because we went basically right over the pad. This is looking good. Oh, that's actually money, chat. Engines on. I don't know why it's... What is our velocity right now? 150. I'm confused as to why it's burning towards the pad even with the engines on. Oh, I do need an or. No, I need the and. No, I need the or. I don't know. I had to look at it, chat. Is that too much derivative now? That might be too much derivative, chat. That was really, really slow to respond. All right, let's see. Well, let's see, chat. So it's now pitching back. It's holding that desired angle. That might be too much derivative. That's gonna be too much derivative. Starting to slow down. It's trying, chat. That was really slow to respond on that maneuver, though. Oh, I know what it's doing there. Oh, I'm so silly. Actually, no, wait. Is it doing it that? Stand by. Stand by. It's trying, that's right. Why is there Python in your game? We're using a mod to communicate Python with KSP. That's what we're doing. So don't worry, it's by design. So we got there. We did get there. Yeah, exactly, Houston. It is afraid. You think it's too much P? Could be. It's definitely a matter of it's definitely just a matter of tuning the controller though, because it is working. You have a lot of integral. KD is same. You know what? Let's increase K over K. Let's increase the derivative term over our integral action. And then we will reduce our horizontal. I don't really want to reduce it because, well, maybe the increase in, we did increase that by an order of magnitude. I'm hesitant to reduce our KP because I feel like that's going to reduce how much pitch it's going to want to give it. And I want it to respond quickly with a significant output. The other thing I wanted to check, chat, is if it does this, see, then it commands pitch. Wait. 1 second. Mode 4. If our distance to pad is greater than 10, else we're going to do this. And if our horizontal velocity speed is greater than 1, we're going to do this. Make sure that those signs are the same. Oh, yeah, that's fine. And then, yeah, okay. No, that's fine. Well, it landed, chat. Yeah, let's run it back. We're going to test it one more time here with those couple of changes. And we'll see. And then we send it, chat. Did I see your text? Which one? You need to tilt away, not to 0 on pitch, so you can slow velocity when coming in at higher speeds. What are you referring to? Because it's not commanding 0 pitch. It's just reducing its pitch at that point. Why doesn't Starship Catch Arms have a wider, more open claw to increase success? Well, they do. They do actually have a pretty wide opening. Or even have the claws parallel with the catch tower, and they spring up or down quickly to be perpendicular with the tower when Starship is in position. I think that's what they actually want to do, right? They want to basically have them swivel like this so they can catch the Starship over here and then slew it on over the booster and then put it on the booster after the booster's been caught. At least that's, to my understanding, what their desired operation is eventually. Not that they'll do that anytime soon, but yeah. You concur with Uber, too much P, okay. Any clues on the weird shimmy away from the target it does when it passes the target? I can only imagine. That's what I was trying to look at. At first, I thought it was this, trying to, at that moment, get to a 0 pitch, but that shouldn't be the case, because if it enters this at all, it's immediately going to its descent. I can only imagine it's because it changes from this part of the controller to now this part of the controller, but I don't know why it does that, unless there's just some discontinuity there, which is entirely possible. Because we're going from track the pad to now null out our horizontal velocity altogether. But I don't know why it's pitching away unless I have oh, you know what I actually should do, chat? I wonder if I should just test. Well, this is the same as this code. There should be nothing different. So if this works, then this should work. Right? So yeah, I'm not sure exactly why it does that. Yeah, I'd have to check. I'm not sure. I mean, it definitely did at some point. because you can see the difference in output somewhere. So yeah, you see that right there? So we're getting close to the pad. We hit 10. Oh, see, there we go. And then it immediately on that change went to negative 15. Oh, that's actually, I think, okay. The reason why it went to negative 15 commanded there is because now it's within 10 meters, so it wants to null out the rates, but that might be too big of a... That might be too big. That might be too ambitious. Because then it immediately goes to 1. That, I think it's that right there that caused that pitch. So when it changes print statements, this is it being more than 10 meters from the pad, and then this is it being within 10 meters. So this is that second control loop. And then we get all the way down to 6. But how does it start? And then it goes outside again. I wonder if I need a deadband or something. No. I'm just trying to think here that maybe we're trying to hit 0 degrees perfectly, right? And so it's not necessarily able to do that. Well, no, that shouldn't matter. I'm actually not trying to do that. Because once it hits this control loop, it should just try to get its horizontal speed less than 1. And then as soon as it's able to do that within 10 meters from the pad, it then descends. So no, I'm actually not trying to hit a target that we would never achieve. But see, we start going past it, and then it has to counteract that again. And then you can see it really respond heavily in that change from positive 15 to negative 15. Deadband's never the answer. Yeah, I immediately talked myself out of that one for sure. All right, let's reduce this. I'll leave the derivative term there. I wonder if I need to reset the integral error. I wonder if there's too big of a windup after this entire phase. Because I do it here. I reset the integral windup once it enters the descent from high altitude. Wondering if that would be good to reset again in this tighter control. Anyways. More boosters, more stages. Yes, all the modes and stages, absolutely. All of them. It appears when it's hovering, it's reducing pitch instead of stopping velocity so it won't overshoot. Yeah, I know. I've noticed that too. We'll see if this slight control difference helps in any way. And even if it doesn't, I kind of want to send it up to 70, because 70 is going to be its normal trajectory that I want. So if we spend too much time tuning the controllers from here, it's just going to have to be retuned for the other trajectory, because we're changing so many different parameters. Shouldn't we be putting it on the position controller? Well, I mean, so the position controller seems to actually be kind of stable. Let's look at it. I was thinking it actually looked kind of stable. It's commanding -4 meters per second when we're 15 seconds away, or 15 meters away. And we're achieving that in control mode 4. And then it's starting to go down as we get closer. It honestly might be our distance gain is too high, because we're 10 meters away and it's still commanding 4 meters per second. Like, ideally that would be 1. So honestly, maybe our distance controller gain is too big. with that control mode. Not mode 4. Is it mode 4? Yeah, it's mode 4. Yeah, mode 4. So maybe that. We're oscillating position, not velocity. Yeah, but I was thinking it was because the horizontal velocity controller is overshooting the commanded velocity that the distance controller is outputting. But I didn't confirm that. Right, like the distance controller I thought was outputting, say, 4 meters per second. And then the horizontal velocity controller is overshooting that desired velocity. So right now it's looking good. This part works great. Everything until we hit mode 4. And that's the new thing, right? So I'm happy about that. Like mode 4 is what we just implemented for this stream. And so that's the new dynamics that are going on here. Okay, should start pitching up here to slow down. There we go. Should then come straight over the pad. Yep, there we go. Get into the vertical mode. Oops. Yep, mode 3. We're 70 meters from the pad. We're now burning. Oh, I forgot to change. We're still 200. And that velocity value seems right. Okay. Now it needs to enter the new mode. It should start slowing down. Did it just finally enter the new mode? So that was with reducing the KP. I don't know, it was very slow to respond. And now we're traveling back. I think it's our distance controller is being too aggressive. I don't know if it's a derivative term requirement or if it's just the proportional gain, because it keeps commanding a massive value. And then our horizontal velocity component, our horizontal velocity controller is now too weak to try and match it. I think that's what's happening. So yeah, it might actually lie within the distance controller now. Whether it needs more derivative or what. Derivative would probably fix it, actually. But yeah, I think you're right about that, Houston. This is me, by the way. I'm sorry. I'm just trying to... Oh, okay. My bad. My bad. I'm hitting the wrong buttons. I was trying to help it, and I didn't help it. Okay, Chad? I'm sorry. But anyways, let's send it up to 70 and see what happens. Because it's undoubtedly going to need some more tuning if we send it up to 70. Let's send it up to 68. It'll probably overshoot at that distance anyways, so... Day 7 complete. Heck yeah, dongles. Nice. All right, send it. 70 kilometers, chat. Of course. I don't know why. I don't know why it wants to do that sometimes. I don't know what it is. It has. There's no rhyme or reason for when the game starts making that happen. Spectacularly, yeah, the headline. Indeed. A little off 70 kilometers. Oh, yeah. Ouch. Yeah, let's try that again. Oops. Yeah, I want to hold the S button, chat. S button. Yeah, holding S, holding S. There we go. All right, bringing it back. Now go that way, please. Thank you. Thank you. Thank you. Sheeps. How you doing, man? How you doing? All right. Now we're on track, chat. So now we can time warp. Because this thing is gonna go full throttle until, I don't know, like 35 kilometers. Hope I have enough fuel for this, actually. All right. Seems good. 76 kilometer altitude. Not fast enough. That first time was so it will, and it does. It just can't do it fast enough, Mad Chat. It'll pitch over too far, too close to the ground. Yeah, goal is up. Yeah, go up, please. That is the goal. Otherwise, yes, if it had enough altitude, it could recover from that. It's only at the start, and I don't know what KSP does or KRPC does, the mod that we're using, to make that happen, but whatever. It's just an Euler step integrator. So yeah, I'll show it to you. It's very simple. Multiply your values by dt, right? Where is it? There it is. We have our altitude, which is just our altitude plus velocity times dt. We have a constant value for our drag area, so we can calculate our force of drag, which of course is not realistic either, but this is roughly the average after doing a lot of flight tests, and so on and so forth. Yeah, very simple. Well, I mean, we could get into like Runge-Kutta and whatnot, or adaptive time step estimators, but nah, we don't want to do that. We'll keep it simple with Euler estimator. All right, we're really high, chat. Hope we have enough delta V for this. Okay, so we are 5 kilometers downrange and we are maximizing our output. Let's see what happens. And we're going to time warp back into the atmosphere for a while. There we go. And then we're going to time warp into the atmosphere for a second until our pitch indicator starts maxing out. There it goes. So now we'll turn on our RCS. Still holding that 40. We're now traveling towards the pad, 8 kilometers away. There's our target. And some heating effects. We should start. Perfect, chat. Perfect. I know what's happening. The landing controller, or the landing calculation, because we're coming in so fast and it's not, the landing calculation doesn't account for drag, it exited the modes and went straight to landing because it thought we were about to slam into the ground. So it was sort of working, but at the same time it's not as intended here. Is it actually going to try to track the pad from 8 kilometers downrange? We're 10,000 meters away and it's going to try and track all the way back to the pad. Look at it. It's going to hit. Oh, never mind. Doesn't have enough fuel for that. Landing gear deploy. Oh my goodness. How does the drag coefficient work? So how we found it was we went to physics to aero GUI data. and we found this value right here. CD times S is your drag area. So it's basically your coefficient of drag, which is relatively constant with a non-changing vehicle, so long as it's not going wildly off of its zero angle of attack. And then your area, which also stays relatively constant. So because of course we're changing our angle of attack as we're flying, your CD is changing. But this is how we got that value that we used in our Euler integrator. But if you're asking how does a drag coefficient work in general, it's basically a non-dimensional form of your craft, proportional, I guess you can say, relative to the amount of drag it actually creates. It's usually found either analytically or in a wind tunnel and things like that in controlled environments. All right, let's fix it, please. Fix it. We're gonna try. So that happened because in mode 2 we have this TB calculation, and if it ever goes below 0.5, we hit the oh crap button because we're about to slam into the ground. Yeah. So this one. So I need another TB TB of that, and we don't want to be too low. Let's call it, say, what, 4,000, 3,000. I remember changing this too. We changed this because we changed it to be this way with just the TB because we were doing those small short hop tests right up to like 10 and 20 kilometers altitude, and we were landing with too much fuel. So we actually needed like 2,000 meters in order to flip over and land because we were so heavy. But now, because we're going up to 70 kilometers and we're coming back nearly empty, that no longer needs to be the case. And so we actually need another qualifier here to say, hey, we also have to be less than 3,000 meters, which should still be enough time to do the flip maneuver and landing burn. Because this calculation right here, coming from our hover slam calculation, basically sees us going through the atmosphere at 800 meters per second and is like, oh my God, we're about to slam into the ground. But it's also not seeing our drag force increasing. So yeah, that should now hopefully be fixed. Question mark. Let's try it again. Hold the S button down. Yeah. Okay, good. Perfect. Brilliant. Now we fly. It's more intact. Yeah, exactly. Than the, oh my gosh. Yeah, the oh crap button, indeed. You would love a Monty Python based rocket, wouldn't we all? We are the Kerbal nuts that say me. I mean, how do you get CD? But I guess you just hold it. Oh yeah. So we did it from a lot of flight tests in KSP, using those values that I showed you in the Aero GUI data. Yeah, a lot of flight testing, and then we basically kind of eyeballed it and said, okay, after this much flight time, it looks like it's approximately 3. We could definitely be more scientific about it, but it seems to be pretty close, right? Like for a 70 kilometer apoapsis, we're a couple kilometers off. Like, it's fine. But I like seeing the funny rocket go up and down by itself. Indeed, there you go. I'm glad you're enjoying that. I wonder if this is how SpaceX designed their GNC, iterative GNC with simulation. Oh yeah, 100%. Yeah. Not like this, obviously. I'm sure they were a little bit more systematic in their approach. But yeah, 100%. And then they scaled it into a subscale demonstrator with Grasshopper, right? Yeah. Yep, they did a lot of simulation and then scaled it and did some suborbital hop with their Grasshopper hop tests to make sure things are working. And then, hey, you know, there you go. Now we have Starship and booster landing. Yeah. All right, stand by for the kickover. Under 10%. Yeah, exactly. It gets the job done. Talk about a glow up. Yeah. Yeah, I suppose so. Hey, Titus, how you doing? All right, we are now tracking the pad 5 kilometers away, moving away from the pad at 26 meters per second. So we are pitching down at as high of a pitch down as we can, targeting that 250 meters per second. See what we can do here. More suborbital tests, Sheebs. I don't think Starship can right now really get into orbit without being able to get back out of orbit. Especially with a landing, right? Because the big thing, right, is that SpaceX with Starship has to do what's called a controlled entry, which means that it must have enough controllability, fuel, propellant, survivability. It has to be able to communicate with the ground, all that jazz, because it has to have a controlled entry environment, meaning that it basically SpaceX has to say Starship is going to land within this landing ellipse in the middle of this ocean at this time, and they have to tell FAA and all that to make sure that is good. And if they don't do that, well, then they can get fined. They can be grounded, all that sorts of stuff. So, yeah. So I don't think they're going to orbit yet because they haven't really confirmed that they have a meaningful amount of controllability to even get to orbit and then to do a deorbit burn. You meant to be cool. Ah, yes, of course. It would be cool if they could do that. Can you talk about any IRL projects, or is it pretty locked down? For me, yeah, it's pretty locked down at the moment. A lot of the DoD contracting side of things at the moment. Oh, look at that, chat. Pitching up, trying to slow down. We're at 250 and we're trying to bring it down to 100, so it's pitching all the way up to try and stop. I like it. That's actually brilliant. All right. Oh, tease it. It's now rolling to get wings level to maximize our lift. That's not good though, actually. That's actually really not good. Our distance controller is now commanding movement away from the pad. Interesting. Our distance controller is telling it to move away from the pad now. See, this is what I was talking about. We now have to tune the distance controller for this new trajectory. Don't worry, chat. It's now going to try and get to the pad. Don't worry, it's going to try to get to the pad now. I still need to implement that. Oh crap, we have no fuel remaining. Just get down on the ground now. But anyways. Isn't that cool though? It increases altitude to account for the terrain underneath it. Oh dear. The landing gear coming out is hilarious to me. The landing gear just coming out all of a sudden is like, oh god, oh god. Okay, so yeah, we gotta tune the distance controller now. Yeah. Which one is it? This one? Yeah. So what would that be, chat? Does it need to have a higher integral? Or is the integral actually too high? What would make it start creating a positive value when it was still so far away? If we look at the outputs, right, chat? If we still have them in the outputs here. Oh, we don't. Son of a gun. It was basically commanding to start moving away from the pad, which was causing it to basically pitch up all the way to try and slow down so it could then start moving away from the pad. Is that the integral winding up too much over that amount of time? Yeah, definitely not Kerbal rated yet, not at all. Is it overflowing value? No, it's not overflowing. I'm just wondering if the wind up error is too much, and so then it eventually starts commanding a positive. Because this worked right for 20 kilometers, and I know we're now going up to 72 kilometers, but at the same time, I'm not sure. Yeah, known as the NAM, right, Naps? The Neil Armstrong maneuver. I don't know. What do you think, Houston or Ubernator? I can see. I mean, we could just change the value and see what sticks. I'm not sure if it's just the wind up. So an integral, right? The integrator term takes every time step the error that we are currently at and basically adds it to the next time step, right? It integrates it over time. So you can imagine that if we have a very large error for a very long time, the output from that integral term gets really, really, really big. And then it only can start coming down when we get really close or even on the other side of that value. So I'm almost wondering if the integral term is too high for this, for being so far away. And so the integral term is winding up and starting to give positive values. I feel like a KD is too high. KD is too high for the distance controller. We actually have no KD on the distance controller. So that's interesting. Right, so we have set point, KP, KD, KI, KD. So KD right now, the distance controller for what we just saw is 0. If you control the integral wind up, oh, by capping it, you know, I don't actually think I clamp it. I do have a clamp for that, don't I? I do have a clamp, and that's not the min or max. That should be for the integral, right? Or that's clamp output. Where do I use clamp? I have rate limit. I don't think, do I have it on my old version? That actually might be the problem. Let me see something here. That could do it. Clamping the output isn't clamping your windup error. I don't know. Well, I guess it is because, yeah, you're right. Because the integral is based off of error, and if we're, wait, are we just clamping the output? I'm just wondering if we are not changing the internals and we're just changing the output, right? So if we're like tracking the current error and the delta error, but we're just saying, hey, before you give this as a return, you know, put it in between these values, but the internals aren't being clamped. I'm wondering if that's happening here. So we have the clamp output. So last output there, but current error, delta U, current error, delta T. Where do we use last output? That's up. So output is last output plus delta U. My current thoughts for crew requirements in my save is a crew escape system and a contingency for failure at each key point of flight. Yeah, that should actually give you a lot of logistics to figure out. That it can 100% get crew back independently. That's actually really cool. I like that. If I look at my old value here, commits. For that, this one, go to, do I have it here? Or is this too old? Might be too old. Too old. Is it this one? Yeah, there we go, PID. I just, yeah, new file. Yeah, see, I clamped the integral here. I don't have it here. I think that's the problem. Yeah, I think that's what's happening, Uber. Is I think I'm just saying, hey, you've done all of these calculations. Now, if the output is too big, only output the maximum value. But it's not going up and changing the rest of it. I think that's what's happening. Sir, please, it's too bright. I'm sorry. Flashbang. How do you change that on GitHub? Is there not a way to change that? Is it just there you go. Flashbang out. Let's see here. So update the integral term. Let's see if I can do that here. So if the integrator, so integrator is that part, self.clamp integrator. So it's this one, right? That we need to clamp here. Is it that whole thing? Because we have in my old, we have integrator equals self dot I plus self dot error times dt, where self dot I should be the gain. Let's see. I think I just need to clamp this. Stand by, chat. Let me make sure I'm doing this right before we just completely do something bad here. That looks good. Yep, that looks good. Clamp PID. That is not where I have that. Son of a gun, chat. Yeah, okay. So it should be this one. Looking at my old code. I'm just trying to make sure I'm not... This should be current error times dt. Then I have ki, because this is messing with my mind going between the positional value or positional form and the velocity form. Yeah, that should be it. I just need to clamp that. Okay. So let's actually take this out then. This is going to be the integral term, which is going to be this, and we're going to leave that as is, and then we're going to take this and change this to be the integral term. Yeah, and then now I need to do the windup, which should, I think, just be this. Something, oh goodness. That looks right. Okay. And then I had a integral clamp function. Yeah, that looks good. Can I just do, I should just be able to do the same thing I already did, right? I already made this style. Yeah, clamp out. So that's clamp output. So let's go ahead and take this and put it here. And then we'll do integral term is going to equal that, but instead of output, this should be the integral term. And then instead of that, it should be, I use clamp, right? I have a clamp term. Yeah, so it should be self.clamp. So negative self.clamp and positive self.clamp. That should hopefully do it, chat. And then we have integral term back here. And if I wanted to, we could also just do something similar to this as well. Do I want to do that? I kind of do. Kind of do want to move it to make it a little bit cleaner. We'll do clamp integral. We'll do self.clamp. Yeah, self clamp. Not the clamp. That should actually be the. We could just do self, right? Or we can actually use the integral term. Sorry, thinking about this out loud, coding out loud. The integral term, and then I just want to move this that we did up here. Be here. Okay. And then we can return that. Very nice. And now, honestly, I should just be able to do that here, right? Clamp. We have the integral term, which would just be this. And I should be able to add that output here, right? So I should just be able to do clamp integral with that. Should be self dot clamp integral. And now I don't need this. There we go. I think that should maybe do it. Right? That should do it. Yeah, I think that should do it, right, chat? Sorry. Let me catch up on chat now. All right. Positional form acts on some of the error and velocity works with a change of error. Yes. Well, I knew that, but I was just trying to make sure I got the difference between my two codes. So I think this should be good. I wasn't aware PIDs came in two flavors. Yes, they do, Houston. I mean, yeah, technically. Their function is the same, but their design is slightly different, just what they work off of. So change versus actual error. So change in error versus actual error. I think that should work. We'll see. If it works the same and nothing broke, then we'll be good. So yeah, hopeful that should do it. That was a little brain teaser going between the two forms and the two codes. What we got there in the end, chat? I actually think what threw me for a loop is just how bad my former PID.py was written. It was a little confusing, the terminology I was using in that old code. Okay, let's run it back, chat. Let's see if the PIDs work. Nope, sorry. Wrong value. There we go. Hey, look at that. It didn't do the Astra slew off the pad this time. All right. Let's go ahead and time warp up. Looking good, chat. Looking good. So again, this should go to like 30 kilometers and then shut down. There we go. Now I can time warp all the way up. Oh, there you go, Houston. Yep, that can certainly work. All right, enter altitude hold. And boop. So far, the PIDs are not crashing, so that's good. Everything looks fine there as well. Now, the one thing in a perfect world, honestly, we should see the exact same garbage behavior here because I didn't actually change or add the specific clamping. So yeah, well, I guess we'll see there. I'm just wondering how much too much integral action is, right? Because again, every time step that it's doing this calculation, it's adding to that integral because we're so far away. Still going to 250. But we're still also very far away. Looking good though. Still going backwards away from the pad because we're still not getting any atmospheric lift to help start moving us forward. There we go. Now we're starting to bring that velocity down towards the pad. Alrighty then. There's some heat. Still good, but we're now starting to move towards the pad very, very quickly here. We should start to see it pitch up. There we go. It wants to slow down. Our output. Oh yeah, see, now it's going positive despite us being 4 kilometers away. So we're still pitched 40 degrees up. It's saying it wants it to move backwards at 75 meters per second. Positive number means it wants it to move that way. So yeah, that still is the thing. So it's behaving exactly like it did last time, which is a good thing. So making that change in the PID code didn't at least mess anything up. All of them hate. Yeah, exactly. Understandable. And we're flipping over into our landing burn. Yeah. We've seen this movie before. Go ahead and revert. Okay. So what happens if we do in fact clamp this value? So clamp equals 30. I don't know, because I'm trying to think of, like, this is meters per second, so I guess we'll find out. Up, and down. Bring it back. Of course. Go figure, chat. Just go figure. Every time you're like, all right, let's do this. We made that change. Great. And then the game makes it do that. Success. That's right. Just roll it back. Not going to change anything. Just run it again. There we go. It was doing it that time too, but I was able to offset it, so whatever. I don't know. All right, we go again, chat. We go again. There we go. So again, we'll see if it behaves the same, or ideally we see a difference. Does it interfere with the calculations? Yes, but not too much. It essentially changes the rate at which the calculations run, which means it can be a little bit more inaccurate. So yeah, short answer is yes, but luckily not too much for what it was doing. All right, and now we descend. All right. Yo, what's up, Blurgard? How are you? Well, welcome to the stream. Better late than never, right? What's up, Superham? How are you? Yeah, technically SAS is not on when the autopilot is on, when the code is running. Even if you see this on, actually it won't even let me turn it on, so yeah, SAS is off for all intents and purposes. All right, looking good. Let's see what's happening here, chat. Still negative 250, which is fine. We do want that. So if this still does it, then I'm thinking maybe the distance controller needs some more tuning. Nope, it's gonna go positive again. Yep, positive now. That's so strange. Still super positive. Even though we're still 2 kilometers downrange. That doesn't make any sense to me. Okay, now it's going more negative. Now it's trying to get back to the pad. But yeah, that's odd. Does it lerp them? What does that mean? What does lerp mean? It wants to go home, chat. It wants to go over there. Yeah, cool. Indeed. Try KD 0. I think the KD is already 0 for the distance controller. Yeah, KD is 0 already for the distance controller. It's trying to get there, chat. It's trying to make it. It wants to go home. Oh dear. Oh, linear interpretation. Yes, that is exactly what it's doing on the ascent profile, not on the downrange profile. Yeah, I don't know. I don't know if the integral is the problem or not. Or is it? Yeah, I don't know. It's not the horizontal velocity controller. The horizontal velocity controller is doing what it needs to do. Do I change that distance controller gain anywhere in mode 2? I don't think I am. Nope. The only other place I only changed the min and max there. I don't change distance anywhere until the bottom, right? Yeah, I only change it down here. And that's way after what we're seeing. How odd, chat. How odd. I'm gonna try putting a very small integral term, much smaller than now. I want to see if it's the integral term. Oops, I'm trying to fly something that's already exploded, my bad. Yeah, I'm gonna try a very, very tiny KI just to see if that changes anything. Yeah, TB is time to burn, so that should be fine. That's based on the hover slam calculation. No, it's not saying. Uh-oh. Every time, chat. Every time you're like, let's just run it really quick. Nope, never. KSP doesn't want you to do that. No, it shouldn't be, because where were we last time? We were in mode 4. Oh man, I forgot. It went too far. I mean, we can keep an eye on that and see, but I don't think that's what it is. No, it's definitely not, because the outer loop, right, the output from the distance controller is going positive when it should stay negative. So even if it was getting into mode 3 still has the same controller, and it should continue to be negative, trying to get towards the pad. Because in mode 4, you can see mode 4, when it was moving towards the pad, it was commanding negative 127 meters per second. So that's correct. That should be correct. So yeah, it's got to be the integral term. So can only imagine. Although I don't know why clamp 30 wasn't changing anything, unless this is a result of like clamping it at 30 is still too large. I'm not sure. There we go. We'll do it again, chat. We'll do it again. Yes, it is, Uber. Yes, it is. I'm feeling it too after a day of work. All right, so yeah, see, AP1, we were targeting 70. Oh my God, we burned really high. So that's what happens when you time warp. The calculations were happening too slow, and so we way overburned our target. But anyways, I should have been more mindful of that, because technically we're changing the test conditions, but whatever. All right, let's time warp back. And we'll continue time warping. And we're gonna watch until our pitch. South Park, good, nice. All right, pitch is increasing. We'll turn on RCS. Is it just me, or did we go further? Oh, I guess that makes sense that we went way further downrange. Yeah, we're at 10 kilometers already. We're starting to now fly towards the pad, which is good. Don't worry about that. Some minor aerodynamics. Yep, see, it's positive though. It is very positive still. Now it's the maximum positive rate. It's so strange to me. So is it the KP value just being way too aggressive? Way too high? Why is it not? See, now we're moving away from it, so... Or is it... This is odd. Uber. Yeah, the KP value being too high, and so it's just being way too aggressive. I mean, that's the only thing it can possibly be now, right? That's like literally the only thing it can possibly be now, because our integral term is essentially 0. I mean, we reduced our integral term by 2 orders of magnitude. Oof. So yeah, we can 0 that out completely and test that. Cut it by 50%. Yeah, that's what I'm thinking. Well, let's see what that does, chat. And then we can add our integral and derivative terms back. We shall see. We shall see. Only change one at a time. I mean, so you want me to leave the integral term as it was? 0, 0, 0, 0, 1. Yeah, that's what I had it as. Yep. I would be shocked that changing it by 2 orders of magnitude had no effect on it, but that's fair. You're teaching sound practices, and I can appreciate that. Should definitely continue to take the systematic approach. Classic PID tuning rabbit hole. You're not wrong every time, right? I do wonder, I mean, I feel like if there's any place for like simple linear optimal control, that KSP rocket guidance or rocket control would be the place, right? Because we basically are living in a perfect world with KSP. So if you can design your state space model around your rocket, just a simple LQR controller would be interesting. It would probably perform really well for certain applications. I'm not talking about for this one. We have a lot of non-linearities in this system. Trying to track the pad and using all 3 degrees of actuation and all that jazz. So probably not right for this one, but worth the science one day. Wouldn't it change vehicle to vehicle? Yeah, it would. Yep. Because your state space model would essentially be tied to some of your dynamic coefficients, right? Which would change with your vehicle. Changes with, if I remember correctly, would change with mass. It would change with thrust. I'm trying to remember the state space model for like rocketry. But yeah, it has those sorts of parameters in there if I'm not mistaken. And that would of course change with your vehicle. No, nothing about state space, yeah. It's a whole new world. All right, well, let's go ahead and time warp down. So we're still commanding 250. That's good, I think, because we're still so far away. So I do want to see that. Okay, it's starting to pitch up. We're starting to reduce its required velocity. 7 kilometers. That's going down a lot slower than last time, though, if I am not mistaken. Gonna go positive again. Huh. In almost the exact same place too, right across the borderline. So that did not get fixed. I felt like that was definitely going slower though. Oh, nice, Houston. That's cool, man. Last flight for you? Yeah, fair enough, Ubernator. It can still land on the truck. Yeah, no kidding, right? All right, now it's flipping into burn mode. And see, now it's back to negative. Here, let me go ahead and cut that. Perfect. And see just what was happening here. Make sure that the modes were correct. So it was in mode 3, and it went from mode 2 at an altitude of 35, 39. But it was already targeting a positive pitch. Oh, sorry, a positive value for velocity. Yeah. All right, well, you know what? Just for the sake of argument, to revert. This is a steady state? Oh. Oh, Ubernator. You could be right about that. Now that you turned me onto that, that immediately clicked. Yeah, it's like we're trying to target a point that's not near the pad. Right? Because every time on that trajectory, we're getting here. It's basically saying we passed this point, and it's saying, okay, now go backwards. So we're basically targeting this point, even though we're targeting this point. So that is a steady state error. That could be interesting. So what happens if we go off the walls and do 0.1? That's 2 orders of magnitude higher than what we had originally. Stop. I'm gonna take the clamp off for the moment. It's still being clamped, but at a much higher value, so. Gosh dang it, every time, chat. Every time. Feels like a nav issue, but our navigation is essentially it is essentially a controller, right? Because our navigation is our downrange distance from the pad, and we're controlling that downrange distance from the pad with a controller. 'Tis the Kerbal way, isn't it always? So it is a navigation issue, but it's a navigation issue because of our controller. Right? it's like proportional navigation that missiles use. They basically have a key controller hooked up to your intercept angle. Which is something I want to implement here, because I wonder if that would be a lot more accurate, is by doing like a proportional navigation system. Because I think with a proportional navigation, I mean, that's almost what we're doing, but it's not quite. A proportional navigation is actually a change in architecture, because you're controlling angles and accelerations versus just like a pitch angle directly. Anyways, let's go up. Less time work. There we go. And warp up. There we go. Time warp back down. Turn RCS off, and let's time warp down until we maximize our control. We're getting there, chat. We're getting there. Hopefully this will work. We'll see. If this doesn't do it, then we'll have to do some testing offline. because it's definitely kind of strange. Oops. Well, that's not going to be a good test. Well, maybe it is. Oh, it's still negative 250. That might be good. It's a good sign, chat. Might be a little bit too high. We're still 250. Well, hopefully it'll start winding down here because we're still very high. Velocity, rather. Oh my. Still maxing. Come on now. Come on now. Nope. We're gonna way overshoot, chat. It's way too high. Well, that's what I get for putting it 2 orders of magnitude higher than what we had. It's like, no, stop. Oh, this actually might not even have enough time to land. Oh, perfect. I wasn't worried, chat. Were you? Yeah, so that time it stayed negative. So that's good. It just means it's a little bit, it's a little too high, chat. Yeah, that gain's a little too high. A wee bit too high. And by a wee bit, I mean very high. Like an order of magnitude high. Or I wonder if a higher KP gain would actually just be what solves it here. Because the KP gain should, once we overshoot and get near with a smaller error, should drive down. Oof. Huh? Oh. Huh? They survived. The Kerbals would have survived. Yeah, higher KP gain could also do it as well. You still don't follow? So what Uber pointed out and what I'm thinking happened is that, so we have a cascading controller, right? A cascading controller, you have an input, you have a proportional gain. This is PID 1 with a feedback loop, right? And then you have a second one, and you have another PID, and you have your output, comes back around. So we basically have 2 PIDs in a loop here. This first one, or the outer loop, is our distance controller. And then our second one, which is our inner loop, is our velocity controller. This one basically defines what our velocity should be, and then it outputs our pitch. So what I think was happening was, we are targeting a set latitude and longitude, like 75 degrees by 0 degrees. Let's just call it that, right? Set latitude and longitude. But because we had essentially only a KP, like just imagine KI and KD was 0, and we only had KP, we had a steady state error, which means that our system could only drive it to 75 degrees by 1 degree, for example. And so that was, we were basically passing 75.1 degrees, and that was inverting our desired velocity. It was basically inverting our set point. And so by adding more KI, which reduces our steady state error, that drove our target back towards 75 by 0. That's what I'm thinking that happened. Like, if you can imagine this right here, right? So I'm going to draw this real quick. So if we had our pad right over here, and that's our target, right? And then we had the shoreline. What seemed to be happening was, because we only had a KP and we had a steady state error, because our KI, right, was essentially, it was very, very close to 0. It was essentially 0, right? So based on our current control architecture, it basically virtually moved our target distance to be over here. So we were trying to target like somewhere over here. So as we flew past this point, our velocity, right, went from negative to positive, and positive means to pitch up to try and slow down to essentially try to start moving backwards. So as soon as we passed this point, this threshold here, it wanted to start moving us backwards. So by increasing Ki and now moving our steady state error to 0, we essentially moved that virtual pad target back over to our desired. That's what I'm thinking happened. I don't know, like that seemed to work. Increasing Ki seemed to now actually target the right thing. Oh, that's right. The gift. Do I still have that up somewhere? Is it over here? Not there. Okay, I'll go back to Discord. So I'm using KRPC. So if you're rusty or not familiar with PID systems, this is essentially what a PID controller looks like as you change the gains. So first what we have is a KP. Notice how it never reaches the desired target of 1, and as you increase KP it gets more excited, but it still never reaches the desired target. It only reaches the target when you increase Ki, because that reduces your steady state error. And then finally your derivative term is basically a regulator, and it helps smooth out the entire system. But let's actually, can I pause this? No, I can't. But essentially, you see how we're increasing KP, but we still have a steady state error. We never achieve 1. When we add Ki, we now get a more excited system, but we finally achieve 1, and then you use KD to smooth it all out. That's essentially what tuning a PID controller looks like. And so I think that's why we were getting the inverted, because we were basically here. We were basically targeting a point that was not our desired. It does reach the target, it even overshoots. Yes, but when we changed trajectory, I don't know why, when we changed trajectory, it was no longer overshooting, Houston. Yeah, when we were doing small hop tests up to 20 kilometers, yeah, our gain and everything, I guess, was tuned fine. To where it would reach the target. But as we increased our altitude and our trajectory started much, much farther away, we, I guess, had more error to account for in our system, and so we had to increase the integral. That seems to be the case. Don't know for certain, but that seems to be what happened. So I don't understand why I changed signs. I don't either, other than the fact that it just the gains weren't tuned for the current trajectory we're on. U equals KPE, and E didn't change sign. Where's my, do I have it here? Controllers. Set point minus current sample. If we only had a KP, yeah, I'd have to go through and actually do the analysis, like this, the actual analysis of how it comes out. Because I see what you're saying, but I don't see it currently within the code on how that comes to be, on how like a steady state error comes to be like that. Because essentially the thing that what would happen would be your set point is offset, right? Aerospace engineering. Yeah, so again, this is the velocity term, right? We're using the deltas of the error and not the errors directly. If you're thinking of the Where do I have that code? Do I still have that code up? Ah, blinding light. Is it there? Nope. Gosh dang it. Did I delete it again? Or exit out? Yeah. But I know what you're talking about. Like using the error directly, and then, like you said, just taking KP times error. Yeah. But for the velocity, you're using the delta error. But yeah, I'd have to look back at these individual calculations on that trajectory to see like what was happening in terms of like how we got the flip, because essentially we would just have this KP times delta error, because our integral term was very low, right? So the only way that would happen is if our delta U switch signs, so KP times delta error, so delta error would have to change signs, right? Which would be the current error minus the last error, where the current error is set point minus current sample. Am I missing something? Yeah, how does that? Because yeah, so that would have to change. That would have to change signs, right? Because it would only be a factor of this. Why not just implement it normal and feed it rate values? We could do that too. Yeah, we could definitely do that too. This just takes care of it without having to do the rate calculation beforehand. Yeah, I'd have to run that again and actually output these and see what happens. Do you think aeronautical engineering is a great major? I mean, absolutely. I mean, if you're into aircraft, then aeronautical is the way to go, absolutely. Or if you're coupling aeronautical with aerospace, then yeah, I mean, if you're into space flight, if you're into rockets, if you're into aircraft, 100%. I really enjoy it. I'm trying to get in college in Brazil. Ah, nice. Well, best of luck to you. I think if you are gravitating towards engineering, then that's definitely a good one, though. Yeah, I have to go through and actually see what these outputs are for that. Do I have? I'm already outputting the debug for that, because we could do a debug for this, for like the distance controller, and actually see what's happening here. You know what? I'm kind of interested in doing that, just so we can do science. Do I even have a debug flag implemented for this? I know I used to, but when I redid it, I don't think I implemented it, did I? No, I just call it. That's right, I just call it. Okay, that's fine. So distance. To do here, where I have this. Just trying to see how I have it in my code right now, because I could just do a simple debug, which should tell me all the different values and stuff. So we would have PID outputs, the error. Yep. Wait, so that's the that's the wrong one. The last error, PID. Yeah, okay. Yeah, I'd have to actually change this, right? Because shouldn't that be output, which would be last error at that point? Which would be the current error, yeah, okay. But if I wanted to see these individually, yeah, we'll have to look at that. I'm not sure off the top of my head. Hey, what's up, Audev? How are you doing? Do you have a framework for generating graphs from your testing, like Bodhi plots and such? So not Bodhi plots, but, and I haven't implemented this yet. I haven't looked at this, but a fantastic viewer, Caslo, implemented enhanced telemetry graphing capabilities off of my repository and did a push request. Check this out. Nope, that's private. Gotcha. He apparently integrated my flight system with Grafana, and then yeah, it looks it looks pretty robust. Being able to print out to Grafana all of the different telemetry ports. So I do need to take some time off stream and look at this and see how to use it, and then we can start doing that, and I think that'd be really cool. Yeah, tuning without graphs means tuning based on intuition. That's 100% true. Yeah, I'm excited to see how that could be used on stream. Yeah, I know, right? That is really cool. Do you intend to push this guidance, drastic landing profiles? Oh yeah, 100%. Yeah, we will once it works. Once it works, I will definitely do another push. So let us see here. So we did that. Distance controller, that might be a little bit too high. Let's make that 0, 0, 1 maybe. I don't remember what I had previously where it stopped working, but let's try that for a second. Okay, there you go. Whew. I saved it, chat. We're good. Yep, I did it. We're good. Oh, indeed, ceiling. Well, I guess if you have Python, does MATLAB interoperate with Python well? Either that or we would have to look at C, because you can also use C with KSP as well. I know there's an old mod that used to allow you to control or to output telemetry to MATLAB, but I don't think that works anymore. I think that's really, really old. Yeah, I'd have to figure out how to do that. Otherwise, we just use Python and build our own thing, you know? Oh yeah, does it still work? Have you tested that? Because that's the one I'm talking about, but I thought that was really old and like stopped working or was not supported or hasn't been updated in who knows how long. But if I'm wrong, then yeah, fair enough. Good old MATLAB. Haven't used MATLAB in I don't know how many years. Since Masters, I guess. What would that be? 6 years now? Almost 6 years? All right, almost up to Apo. What'd you set KI to? 0.1. No, 0.01. It used to be 0.1, now it's 0.01. An order of magnitude. Just to see if we sit somewhere in the middle or not. Do you think KSP1 is better than KSP2? I do, only because KSP2 is dead, right? Like KSP2 is no longer in development, so yeah, it's not even a complete game. So yeah, KSP1 is better. If by any default standard other than it's a complete game, KSP1 is better. Ah, gotcha, Ceiling, gotcha, okay. Yeah, by default, KSP1 is better just because it's a complete game. And, you know, has a great modding community that's still active and all that sort of stuff, so. And honestly, with a bunch of the visual packs that have come out in like the last couple of years, I mean, KSP, you can make KSP1 look really, really good. There's a bunch of stuff that's come out in just the past couple of years, like volumetric clouds, parallax that I'm using, and I'm not even using the full. I'm only using like 2 little visual mods. I'm not even using like a full thing that you can implement. So yeah, KSP, if you're talking about just the beauty side of what KSP2 was, KSP1 can probably get there still. KSP1 is better because it runs on Mac. Well, there you go. So yes, sadly, I hate saying that KSP1 is better because I was really, really excited about having KSP2, but yeah, now I guess we look forward to KSA, right? You're excited for Kitten Space Agency, looks promising, yeah. Yep, I will hold my breath for now, but I am definitely excited for its potential. Because we haven't gotten any updates, right, ever since that first like Reddit post just showing the zoom in from orbit or whatever on the moon. Like we haven't gotten another update, right? Still negative 250, okay. 4 kilometers downrange. All right, still too high. What did I used to have this set to, chat? That it's Still maxing out here. I haven't changed anything else other than this. Okay, there it goes. It starts to decrease, but way too slow. All right, trying to get back to the pad chat. All right, landing burn has begun. Well, that's, you know, we're closer than last time, I guess. It's still overshot drastically, though. All right, looking okay. Is it still maxing it out? Oh my god, it's still calling for 50 meters per second. There he goes. There he goes. Start slowing down there. Start slowing down there. Tease it. Oh no, out of fuel. Perfect. A derivative proportional second derivative controller. Yeah. Now we add KD. I guess that's true. Yeah. Guess we could definitely add KD now. You think high? Same order of magnitude? $100% more. I mean, it was started at 0. It started at 0, Katie. They sent some photo updates on the 4th. Oh, gotcha. I haven't seen that. The KSA Discord is very it doesn't surprise me, but I also didn't think about looking to see if they had a Discord. We're landing with this tune? Yeah, I hope so. That'd be nice. That'd be nice. Okay, looking good. Let's go ahead and time warp. Coming up on coast phase. There we go, and now we coast. Why can't we get absolute vehicle position? What do you mean, Audev? We can. We basically do. Like, we don't have GPS systems in the game, so we do get the absolute position. Or what do you mean exactly? It's midnight for you? Yep, it's almost 11 for me. You're in shambles. All right. Sounds good. Oh no, we do, Audev. It's just a matter of tuning the controllers, right? I think that's really what it boils down to. Also, we're trying to do this essentially controlling effectively 2 axes and not all 3, because the way the current KRPC implementation for a controller is called autopilot, and it uses heading. So instead of doing pitch, roll, and yaw, we effectively do pitch, roll, or well, we do pitch, and then yaw and roll are coupled to give us heading. So we can effectively only directly change our pitch, while we indirectly change our roll and yaw. At least that's how I understand it. So if we really wanted to get more accurate, I need to get down in the weeds and develop our own flight controller that can start using direction vectors, like the actual vectors between us and the target, instead of just giving us angles to then track, right? So we're basically giving angles instead of a vector to vector direction to try and match. So there's a lot of things that we can do to be more accurate, but really this is just a limitation of PID loops that are not being tuned to 100% accuracy right now. I appreciate that, Autov, yeah. And if you know how the autopilot works with heading, I'd really love to know more about that. Because it's not like doing a yaw input like A and D is in the off of a keyboard, right? So I'm not sure how that gets translated into actual control inputs. That's what I'm currently not sure about. We're still really fast. I would like to see this start coming down at this point. Yeah, I think our gain is still too high. Our gain is still too high. Yeah, way too high. Uh-oh. Uh-oh, chat. Uh-oh. Come on, tease it. Tease it. Tease it. Yeah, I think they're coupled. I'm pretty sure that's how that works, because it's not the same as pitch, roll, and yaw. It's pitch, roll, and heading, like compass heading, which means that whatever you set your roll to, like if you set your roll to 0, meaning wings level, and you're basically going vertical, then your heading is going to push you in one direction and roll you at the same time. Try and match that at all times. So yeah, it's not the same as pitch, roll, and yaw as far as I can tell from the documents. Okay. Let's try doing 0, 5 now. I'm curious to see if that's actually the cause here. Yep, that time it didn't do a chat. What if you do a translation layer? Yeah, that's what I'm thinking about doing with the flight controller. Yeah, that's what I'm thinking about doing. But see, I have that kind of started. I haven't tested it or anything like that, but essentially it sets up you give it a target direction, and then based on your current vector and the error between your body vector and the target vector, it then tries to slew and match that, drive those errors between all of those angles at the same time. So ideally, something like this can work. But yeah, that's a whole nother rabbit hole. Hey, all good, all dev. I'm glad you're enjoying the content, though. All right, let's go ahead and coast all the way up, chat. And we'll see how this goes. So hopefully, ideally, this slightly smaller integral term will keep us from maxing out our designated velocity, commanded velocity. I know, right? Just one more, please, just one more. Just one more, bro. Just one more flight, bro. I'm not okay, I know, right? Okay. Oh. Okay, for a second. Oh, okay. That was weird. Okay. Interesting. Well, we'll see. We'll keep an eye on it. Okay, looking good still. So even that? Okay, now it's starting to, but we're still way too close and still not dropping fast enough. Huh. Well, at least it's able to turn around and still track the pad. Still gonna overshoot though. Is it the change I made with the clamping? Is that doing something to this? Because I feel like we're back to almost where we were, and see, it's still doing 150. Like, there's no way. And I feel like we're close to what we had. Is that the derivative term being too high? 160 meters per second. Might have to take some time and check this out off stream. Should land at some point. Sick and tired of explosions, chat. Their account is getting deleted because I own the number now. Oh, wow. Okay. There you go, Isaac. I guess. So, yeah, exactly. Saying that's something I would like to do as well, is implement quaternions and not Euler angles. 100%. Yeah, I'd like that. Yeah, Uber, I'm right there with you. Oh man. Yeah, that's so strange. Because like, what did we have before? What did we? The only thing we changed would have been the clamp. I want to see if that did in fact change something. I don't think it did, because I remember it behaved the same way beforehand. So you know what? No. So either the derivative is too high, and so now it's it did indeed land. Now either the derivative is too high, and so it's really slow to respond, or the KP is too low, and so it's not able to drive the error down fast enough. I'm kind of interested in that. Like, is the KP? What if we change the KP to be like stupid high? This is probably not going to work out. I'm just interested. I'm wondering if like the KP is not big enough to where, you know, we essentially have a massive oscillation, right? And so it's not able to drive the error back towards the target. Yeah, we'll see. This is gonna probably be the last one. I just want to see if KP changing it to be high like that has any effect on its ability to slow the response down. It does land when out of fuel, that is true. Every single quaternion library doesn't work. Interesting. I haven't even looked at those yet. Probably would just try to implement my own. I mean, I feel like quaternion math should be fairly straightforward. So if there's a library out there that doesn't work, I find that odd. Oh, absolutely, Andy. I certainly do. There it goes. That was just KRPC being a little strange, I think. Yeah, there we go. Now it's locked in. Too much control authority on those nose thrusters. All right, let's check it again. Ah, okay. Oh, it's gonna be too high though. It's gonna be too overreactive. Interesting. Yeah, I'll have to look at that and see why that is. So that's off of the KP. Yeah, off stream I'll have to print out those basically the output and see where and why the error is going negative like that. Because you see, it's basically saying we're right over the target right now because it's commanding almost 0 velocity. And that's really strange. And then when we reset, oh, wait, hold up. Do I reset the error in mode 3 or no? I do. And then immediately, wait, no, it should be the opposite. Oh, chat, it's going to take some debugging, that is for sure. See, look, it's moving away from the target right now. Which means it's basically targeting something over here. Huh. How interesting, chat. Well, I think that's going to have to do it for me, though. I think that's a good stopping point, chat. That's goodness gracious. Yeah, I'm going to have to print out what those errors are and see why that's happening. So I do find that strange that your distance, your outer loop is flipping the sign, which is essentially acting almost like a steady state error, but we do have an integral term. Yeah, I'm not sure what's happening there. It is interesting. It wanted to swim, clearly, yeah. Anyways, chat, that's gonna do it for me. I hope you guys enjoyed the stream. Next stream will probably be Wednesday, starting at 7 p.m. Hopefully I can kind of figure out what's going on in the back end of this code currently, see what the difference in the velocity form of the PID loop is doing at that point for the steady state error or whatever is going on there. We'll figure it out. But anyways, chat, I hope you guys enjoyed it. We'll be back here Wednesday night, 7 p.m. Mountain Time. And yeah, guess I'll see you there, chat.